Hi, today I'm going to give you an introduction of chapter 28, the atomic physics. Use this still study the lecture for the detail. Okay, section 1, early model of atoms. Okay, we have studied last chapter the STM machine. Okay, so that's 1980s. First time scientists can see the atom directly. Uh, you see the cone, that's one, two, three, four atom. That's the first time. So now, what is the inside of atom? Where's the nucleus? The proton, neutron, and where's the electrons? Well, we have idea, but we cannot see. We cannot observe directly. Not even today. Uh, so now, discovery of electrons be more than 100 years. And here's a very famous experiment we call Millikan oil droplet experiment. So now this is a lab for physics class. Most major university has this experiment. So simply speaking, we can use oil droplet. You just squeeze here, then oil droplet. This is a special design. So every the particles droplet has almost same mass, same weight. Okay, so when they come out, they collect each other. Some catch electron, some the loose electrons. So let's concentrate to the one catch electrons. Become negative charge, right? Negative charge. So now when the oil droplet pass this chamber here, we have two plates, metal plates. The top one add positive, then bottom one negative of the battery. So positive, negative. So now let's say one droplet come here. Because gravity, the droplet goes down, but electric force push up, right? Because the particle carry negative charge, and these are positive. So one force, gravity goes down, electric force goes up. And now you can adjust, you can change the voltage until the droplets stop right here at the middle. And you can see it, use a microscope. So now you can see the particles stay right in the middle. Electric force up equals gravity down. So then you use the equation. Okay, we have both equation for two forces. Then you can calculate electric charge. That's how scientists find the charge of electrons equals 1.6 10 to the power negative 19 coulomb, and it's negative. That's how find electrons. And they find the charge always equals 1 electrons, 2 electrons, 3 electrons, always integer times this value. That's how to find the electrons. So now about the nucleus. That's 100 years ago. Okay, so now the name is Rutherford. Rutherford. He's the first one to find it. And he spent 4 years for this experiment. So simply speaking, he used alpha particles. It's positive charge. Every particle has positive charge. Positive charge. Now you see there's two small hole here. You make sure the beam pass it, pass that, then go to a target. Okay, so he used gold as target. This very thin foil, very thin. That size, very small. And he wants to see what happens. And this green one are detectors all around. All around. So he find when the alpha particle with positive charge strike the target, what happens? most of them going to pass through, and you can measure signal around this area. I will say more than 90% go straight out. Some going to change direction. I will say 50 of the 1,000 going to change direction, go this, go there, different direction. Very few come back this way or maybe that way. So from this experiment, Rutherford gave a conclusion. Inside of atom is empty space because most of the particles just pass through. Only few change direction. So we're going to discuss more detail in chapter 29 and 30. Chapter 29 and chapter 30 when we study nuclear physics. So conclusion is inside of atom mostly is empty space. Nuclear so small, like a blueberry in football stadium. That's how small is the nuclear. And we know the three, okay, here's conclusion. Atom is mostly the empty space. So compared to atom, nuclear so small, 100,000 times smaller. So we know proton, neutron together make the small part of the nucleus. And the proton carry positive charge, neutron carry no charge. Scientists find the neutron 30 years later than this experiment. So then electrons. The proton, electron, same charge but one positive, one negative. Masses. Proton, neutron are much more heavier than electron. This is very important. So much heavier than electron. So then the second one is spectrum. We formula this one. We have emission spectrum, which is bright line on dark background. And also we have absorption spectrum, which is dark line on the bright background. Okay, so let's study the first one. And here it's set up for the spectrum. You have a tube. Inside you have different atoms. You have one tube for hydrogen, another tube for neon, helium. Okay, so now when you add voltage, the atom absorb energy, then give off light. Okay, then we use this one here, we call grating. We can separate different color, and we see which color from hydrogen, which color from mercury or neon. This we call the spectrum. So the dark background, bright line, you can determine the frequency of wavelengths of this light. So hydrogen always give you this color. The mercury give you more color like this. And neon will give you different color. They're just like a fingerprint, okay, of atoms. From this different color, we can learn inside the atom. Okay, so now this one we call absorption spectrum, which is if you, okay, for example, if you watch, I use this one, watch sunlight, where you need some protection, you need a filter. Okay, otherwise light speed too strong. So then you find, okay, you have all the colors, different frequency, but few lines missing. So background is bright and line is dark. Why? Because atom and molecules in atmosphere observe those frequencies, so they're missing. We call absorption spectrum. Okay. So now scientists want to know why. Why different atom give you different color? And this color tell you what? We know the different frequency like this purple, blue, green, and red. That means different energy, right? Because energy of the light, photon, equals constant time frequency. So scientists want to know why inside of the hydrogen give you these four different frequency, and mercury give you different frequency. We call them different fingerprint of different atoms. When you check the spectrum, you know what you have in the sample. So now the first scientist gave the answer. It's Bohr. We call Bohr theory. This is a very simple theory, and this can only explain what happened to hydrogen, which is this one. Okay, so that was 100 years ago too, and he also won the Nobel Prize. Okay, let's see the model first. So hydrogen is very simple. One single protons, one electron circle it. Just like a moon circle the Earth or Earth circle the sun. We have circular motion. So circular motion require what? Centripetal force. And also between the positive charge proton and negative charge electron, they have electrical force. So these two forces must balance each other. So the centripetal force must equals electrical force. That's starting point. Okay, centripetal force equals electrical force. K is constant and E is charge because we have a same charge, one positive, one negative. So proton and electron attract each other. Why they don't collide each other? Because the speed of electrons keep circling. So they just balance. Just like a moon circle the Earth, never collide each other. So now Bohr try to explain what happened to this spectrum. Why we have those colors. And he tell us we're going to skip the mathematics, only discuss the conclusion. He said under the electrical force between proton and electron, electron just circling like this, make a circular motion. Okay, so if don't give any energy, electron just keep circling. Okay, so now this circle, we give a name, we call ground state. Ground state. Now, when you give energy, just like this, sorry, I go back and forth like this. When the atom receive energy, then what happens? The electron can go higher energy state. Go a bigger circle, even bigger circle. Well, depend on energy you give to. Okay, and those we call excited state. And now we have to give a number. So first one we call ground state. We say the quantum number equals 1. Then other circle we call excited state. We call the quantum number equals 2 or 3 or 4. So ground state, excited state. Okay, so now if we say that, see this demonstration. One circle n equals 1 equals 2 equals 3. So when you give energy to the atoms, the electron will go higher energy state. So now, let's see what happens next. So now, the excited states are unstable. Electron just cannot just stay there. Like you throw a keychain, you throw a steel ball up. Not going to float in the air, right? Will come back. So now, when electron come back from high energy back to low energy, the energy decrease. But because conservation, the energy had to go, then give you what? Give you photon. So that's the reason. Look here. So when atom absorb energy, electron will go higher and higher energy level. But they are not stable. So electron will come back. Say, let's say, here's from Third one back to second one, you're gonna see the red color. From number 4 back to number 2 will give you the different color. That's green, let's say. Blue color because this more energy change, give you different frequency. And next one will give you different color. Of course, they can also come back to ground state, but this frequency we cannot see. Because there's more energy, that's more like X-ray, or something we cannot see. We can only see certain color. So anyway, when electrons go up to higher energy level, we call it excited state. They're unstable. They'll come back. When they come back from high back to low, the energy come out as a photon. Different energy give you different color. That's the reason. So Bohr model, this theory, I gave you some detail at the end of the chapter. If you have time, you can read it. So we're going to concentrate to the concept. Bohr's theory can explain what happened to hydrogen. Because it's simple. Hydrogen only has one single electron. It's very interactive, but this theory, Bohr model, cannot explain more complicated spectrum. Okay, if you have more than one electron, this theory is not enough. So we need a new theory. The new theory we call quantum mechanics. We are not going to study this for the graduate school level for physics major. So well, sometime in if you study physics in major in your senior years, maybe junior years, you're going to study quantum mechanics. So we're going to only give you some conclusion. So now the quantum mechanics tell us, well, if you have more than one electrons, that means other than hydrogen, you need more energy level. So this is first one. That's the second one. And the third one, and number 4. Because if you have 80 electrons like Mercury, it's not like all the electrons stay at the same circle, same energy level. Okay, some going to stay the first one, some stay the second one, some stay the third one, and the fourth one. Depend on how many electrons you have in an atom. Okay, and also, so this we call energy state or energy shells. Okay, first shell, second shell, third, and number 4. And now each energy shell has subshells. Okay, so when n equals 1, that's only one single shell. When n equals 2, you have 2 subshells. N equals 3, 3 subshell, 4 and 4 subshell. So now you have more and more and more room. You can have more people. Have more electron state in the energy states. Okay, because like first floor, second floor, third floor, fourth floor, you have more and more room. Or you can think like basketball arena. Okay, the first most close to the center, you only have 100 seats. Well, you pay $1,000 probably. Now the second circle, you have 200 seats. And then bigger and bigger, have more and more room. Think that way. Okay, so now again from the quantum mechanics, we're not going to study the theory, only give the conclusion. Now, when you add a strong magnetic field, so if atoms between a strong magnetic field, what happens? This subshell going to split even more shell. Okay, so now, okay, so suppose this n equals 3. N equals 3, you have 3 subshell. Okay, the first subshell going to give you only 1. The second subshell going to give you 3. Oh, that's all under magnetic field. And third one give you 5. Okay, so we're not going to discuss the detail. I just tell you, when you have more and more rooms, and more electron can stay. Okay, the last one, scientists find even more detail we call fan structure. Uh, okay, so electrons inside of the magnetic field can either goes up or goes down, goes up or goes down. Okay, so we give another quantum number, say half and negative half. Two chances, either up or down, half and half. Okay, so now here's the key. So now the electron inside the atom becomes so complicated. So here's let's go that figure again. Uh, okay, here is hydrogen. Electron can stay the first circle. Uh, so now this helium. Uh, okay, second electron because helium has two electrons. Stay here, stay there. They try to be as far as possible because they repel each other. Both has negative charge. So both in first circle. So now the third one, this lithium has three electrons. First one, second one stay in first circle, and last one stay in the second circle. See, n equals 2. Okay, so now this is next beryllium, 4 electrons. 2 stay inside, 2 stay outside. Why we use a different color? Because the outer shell, which is number 2, most important for chemistry and for physics. Because inside so close to nuclear, not going to change. These two easy to change. Okay, so now if you study the periodic table, this second period, first period only have two elements, the hydrogen and helium, and boron, 5 electrons, 3 second one, and carbon, 4 in second one, nitrogen, 5 green in second one, first one always 2, and okay, oxygen 6, fluorine 7, neon 8. Okay, totally 10 electrons. 2 stay in first circle, 8 stay second circle, totally 10. So when the second one has 8, you cannot hold anymore because run out of the room. Remember the shells, subshells. So second one only have 2 subshells. This one closed. So then we start the third one. Okay, so we change the first one and the second one become yellow because closed. Okay, so now you have a first electron in the third shell. Okay, so remember the maximum number for outer shell is 8. So now how we can tell the difference of those electrons? What's different between these two? What's different between these two? Well, we will say they have a different quantum number. They have a different quantum number. Just like students have different ID. Even your twins, you're supposed to have different student ID, right? So electron cannot be same. Something must be different. So they all have different quantum number. So we're going to continue this. Okay, so for atoms that has more than 1 electrons, every electron has 4 quantum number. Please remember. Every electron has 4 quantum number. So we say 4 quantum number are needed to determine the energy, the motion, behavior, and orientation, all the property of electrons. Every electron has 4 quantum number. The first one we call the principal quantum number. That is n, the first quantum number we already discussed. First energy shell, n equals 1, second energy shell, n equals 2, and n equals 3, 4, up to 7. Okay, so this one tell you the energy. Bigger number means higher energy. The second one give you subshell. The subshell we call the orbital quantum number. This number depends on n, smaller than n. If n equals 1, L equals 0. When n equals 2, L can be 0 and 1. Okay, so if n equals 3, then L can be 0, 1, or 2. Always equals n minus 1, the maximum. Okay, then under magnetic field, we have more room. Okay, so this quantum number we call magnetic quantum number depends on the second number. The last one we call spin, SPIN, give you the orientation. Can be only two possibility, either positive or negative half. Okay, because that reason, and because every electron need have different every electron need to have different quantum number. Okay, so every electron has N, L, M, L, Ms, 4 quantum number. At least one number must be different from other electrons in same atom. You cannot have two electrons that have the same quantum number. Okay, so when n equals 1, first quantum number, now the second quantum must equal 0, and third must be equal 0, and the number 4 can be positive or negative, so the first one can hold up to 2. Okay, so now when n equals 2, the first quantum number, now the subshell going to have 2, 0 or 1. Okay, so then you're going to have more room, and each room you can have positive or negative, so totally you can hold up to 8 in the second one. The similar reason, the third energy shell can hold up to 18. So, well, we had to go back and forth. You can see more and more room. When n equals 1, you can only have one room. You can have two electrons, one goes up, one goes down. When n equals 2, you can have up to 4 room, 2 in each, so total is 8. Similar reason, you can have 18 in the third one. But there's another rule. I will not ask you all the detail. You just need the basic concept. Okay, so now the real theory is much more complicated. For example, the quantum mechanics tell us electron cannot stay in like a single circle. So it's more like we call electron cloud. You see this dark area? You can find electrons everywhere. Then the cloud can be even more complicated. When n equals 1, it's like this one. When n equals 2, can be like this one. And when n equals 3, can be like that. More and more complicated. We are not going to discuss detail because the 3 dimension. The electron can either go up, down, along the x direction, y direction, or z direction. Very complicated. Okay, so now here's the 3 basic rules. All this come from the theory of quantum mechanics. Rule number 1. Each electron must have a different quantum number. Each electron has how many quantum number? 4 quantum number. Every electron has 4 quantum number. Now, the atom is more stable when the total energy is minimum. Well, that means electron always go inside first. When first one closed, then go second one. Second one closed, go third one. So now number 3, the outer shell, the last energy shell cannot hold more than 8. 8 electron is the maximum. Okay, so now let's go back to this again. So let's go. Okay. So after neon, this if you study a periodic table, that's the second period. Okay. So the second inner shell has 4 plus 4, 8 electrons. So second one closed. Second closed. So then we start third one. So this sodium, again, first one closed with 2, second one closed with 8. So we only discuss the third one. Third energy shell has 1. Magnesium has 2. You see, 1 and 2. Okay, so next one's aluminum has 3. And silicon has 4. Phosphorus 5, 6. This is sulfur. Chlorine has 7. You see, 4 here, 3 here, and next one, argon. Argon has 8. No, the last energy shell, which is number 3, cannot hold more than 8. We do have more room. The third one can hold up to 18. There's more room for third one. But you cannot do that because 8 is the maximum for the outer shell, last one. Okay, so then the natural start number 4. Okay, after 8 electrons in number 3, okay, next one go number 4, potassium. Okay, then calcium. You see 2 in number 4. Now see something interesting. So now scandium. Next one in periodic table. This one you see 2 in number 4. Then the new one comes to number 3. Why? Because now number 3 is not the outer shell anymore, so electron can fill in. So after you have 2 electron in number 4, shell number 4, the next one come back to number 3. So that makes things more complicated. We call transition elements in periodic table. Okay, so that's 2. Okay, this is something else. Okay, so let's close this one. Come back to our lecture. So here's a few things I want you to remember. Every electron has 4 quantum number. The 4 quantum number give you the information about the electron. What is the energy? What is the angular momentum? Behavior under magnetic field, and orientation. Give you the whole information about electron. Every electron has 4 quantum number. Then the outer shell, the last energy shell, cannot hold more than 8. 8 is the maximum. Oh, that's more detail. We're not going to study. So when we study the chemistry, and we can discuss why the hydrogen and alkali metal, that's first column. Okay, they're so active because they only have 1 electron in outer shell. The halogens elements, they're also very active because they all have 7, just need 1 to close. The noble gases, they all close with 8. So that's why they're very inactive. That's all reasons. So why we should believe this? The spectrum and electron in different energy state, can we see those states? No, we cannot. Not even today. But we studied from different angle. The spectrum, different atom give you different color have different frequency, different energy. That is physics. Then quantum mechanics, basically is mathematics. So people use differential equation, use mathematics, calculated the energy state inside of the atoms. The theory just match with the experiment. Okay, the third one, the chemistry, since Mendeleev. Mendeleev didn't know the energy shell. There was no such theory. But the chemistry people studied chemical behavior, different energy state. Okay, they didn't know, but they can study the behavior. So different period, different column, the property of the different elements. So all the three just match with the same thing. So the chemistry, mathematics, physics all tell us same thing. Like the periodic table just match energy shell. Periodic table just match the energy shell. So all the elements in first period, one energy shell. All the elements in second period, two energy shell. Okay, so we don't have a chance to discuss more detail. So anyway, chemistry, physics, and mathematics give us same thing. That must be right. Just like if we have students, we have a few students in physics this semester. So okay, if I give you a problem in the test, you all have the same answer. Most likely you're right? But if you have a wrong answer, you can have all kind of different answer. Okay, so that's why we cannot see the energy state inside of the atom. We cannot see inside the atom, not even today. But we believe this is a very good theory because it's matched with experiment. Okay, this is the end of this chapter. Thank you.